computer's dying.
Because of Firefox.
It might be Firefox. I think it's just the Mac is not able to handle it. All right, we're in Precalculus, lesson 3-11. It's Pi Day, so I'm going to write the date, not European style, as Emma predicted, and I'm going to say 3/14. So it's Pi Day 2023. And we have our last lesson before our quiz. So just as a reminder, we are here and quiz is tomorrow. All right, so from here, I'm going to, I think, just jump in with an example. I think that's the fastest way to teach. Example number 1. Let's try this one. Let me give you log of 4 minus log of x is equal to, not feeling very creative. 6. Perfect. How do we do this problem? We're solving for x. Again, all of these 3 dash, was it 9, 10, 11 are all solving for x. How do we do this? Any ideas at first glance from Zoom kids, Diego or Emma? How do we do this? I have 2 different logarithms. You've learned how to do this.
See, is that they both don't have a base.
Yeah, that will affect us later, definitely. Yeah, because if you don't see a base, you assume the base is 10. Yeah, go for it.
So if you take,
You're talking, but I forgot that I muted the Promethean board. My bad. Wait, is it the Promethean board? Hold on. What did I say my sound is coming out of? Sound, it is coming out from the Promethean board, and the Promethean board is on mute. Now we can hear you. Try it again.
can you hear me now?
Yes, we can.
Okay, so since there's no base, it's just 10. If you do the 10 to the power of log 4 and you just get the 4, can't you just get the 4 and then solve it like an algebra problem?
Get the 10. I'm here. Can you tell me exactly what to write? Because I'm a little bit confused.
Okay, so what you were saying, to get rid of the logs, you change your base, so it's log 10 of 4, and can't you just do 10 to log 4?
You could, but the problem is you're going to have all of this log 4, log x in the exponent, and they don't cancel out. They only cancel when you have a single logarithm.
You can't do it like one by you have to do them together.
Yeah, you can do exponentiation. You exponentiate each side of the equation. You can't exponentiate each individual term. You can't do that.
I have an idea. We could like rewrite it so it's log and then like in parentheses 4 divided by x.
Exactly. Turning it into one logarithm is the correct first step. So if we write this as log in parentheses, and you said, why did you do 4 divided by x?
Yeah,
Why?
because it's subtraction.
Yep. Subtraction on the outside means division on the inside. Exactly. Subtraction is the key takeaway. And we haven't changed anything on the right side. Now that we have only one logarithm, we're going to do Chloe's step of exponentiation. And we're going to say this is now, there's a hidden 10 down here. And Chloe didn't choose the base correctly. It's 10 to the power of log of 4 divided by x on the inside. And if I do exponentiation with 10 as the base on the left, you do exponentiation with 10 on the base for the right, 10 to the power of 6. And then it's the same steps as yesterday. Cross, 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 right? Am I lagging too bad? You guys can see cross, cross. There's no other base to cross out. Leaving us with 4 divided by x is equal to 10 to the power of 6. Ooh. Well, 10 to the 6th power, we could expand that if you want. Sure, because we know that off to the side, if I have 10 to the power of 7, that means I have 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. There are 7 zeros. So we can expand that, yeah, let's do it. So this is not gonna be 4 over x is equal to 1 with, how many zeros? 6, 1, 2, 3, 4, 5, 6, a little bit of lag, cut it pretty quick though. Now what though? Multiply, if we multiply by 4 on both sides, what will happen is I'll get a 16 over x on this side, and I'll get a, what's this, 4 million on that side.
Okay.
So you could, but I think that just makes it harder.
Yeah.
Chloe?
So since 4, like when you're dividing two fractions, you flip it and then you multiply, so, or I guess no, it's the opposite. Wouldn't you just do that a million divided by 4?
You do. And can I explain the reason that I do it? So technically, this is a fraction equal to a fraction. I'm gonna go ahead and make this a fraction equal to a fraction. Yeah. If it's a fraction equal to a fraction, you're allowed to cross multiply and solve. Oh, so I guess, does that mean that Chloe was wrong? No, you're not wrong. You can still do it that way. So watch this. Whenever you have a fraction equal to a fraction, you are allowed to switch any diagonal. Chloe decided to switch this diagonal. This 4, this 1 are allowed to switch, which means you have 1 million divided by 4. That's what Chloe said, right? 1 million divided by 4. You can nod your head. Is that what you said? I'm trying to remember. That's 100% correct. However, you'll have a second step to do, and I can do it all in one step. So I'm going to show the most efficient way. Instead of switching these two diagonals, I'm going to switch these two diagonals. Yeah, so watch what happens if I do those two diagonals instead. Then I'm going to have 4 over 1 million and x over 1. And x over 1 is just x. Yep. Yeah, so I don't know, I'm trying to be nice. Like Chloe, you were 100% correct. You would have had to do it in 2 steps. Mine just did it in 1 step.
So instead of doing a million divided by 4, you just do 4 divided by a million?
Yeah, so let me show you what would have happened in your case. You were right. What you said is 100% correct. If you do a million divided by 4, you'll get the right answer. But what if you did it your way? I'm curious. What if you had 1 over x is equal to 1 million divided by 4? Because that's mathematically correct. The next step in your system, Chloe, is this x is in the bottom, so switch it. You take the reciprocal of the left. If you take the reciprocal of the left, you also have to take the reciprocal of the right, and you get x is equal to 4 over 1 million. I got 6 of those. Yeah.
Wait, so do you still divide it then, or it's just 4, or just x?
I guess in my mind, that second step you did is, I just never really thought about it. In my mind, it's the same thing.
Okay, yeah, so there's a lot of different ways to do it. I mean, I'm thinking about the final answer right now. It's not completely done.
Oh, your computer.
Oh, Ashton, where are you? Oh.
Maybe that's why I was getting laggy.
Can they even hear us right now?
Can you hear us?
I think it's on mute right now. Oh, they can hear us.
Okay.
My laptop just died, and my laptop's the thing that my iPad is connected to. And not to blame Ashton, but I'm blaming Ashton. He borrowed my charger and he didn't give it back. All right.
I cannot with him anymore.
I didn't hear that either. That is open. Go to Zoom. Zoom. Okay, I'm gonna do this in a more roundabout way, really showing how well I can juggle technology here. The reason I don't want to do it this way is because I had 21 seconds of lag. Shall we see if it's that bad again? Oh my God. It's going pretty fast now. So if I come back to Zoom, see, and I share the screen through the Promethean board, share screen on the Promethean board, and if I switch back to screen share, they can see what I was just doing. And this is where we really test to see if there's bad lag or not. Feel better. All right. And I don't know if Zoom is still recording anymore. I guess we'll figure it out later. Sorry, Giorgio.
How do I save this?
Yeah, we got our final answer. We can reduce the top and the bottom by dividing by 4 divided by 4, making this 1 over 250,000.
That's way better than
Oh my God, it's faster now?
Yeah.
All right, I don't know why it's back and forth. There's your final answer.
I'm gonna go and turn it in.
Wow, that is way faster.
But so you divided both, or 1 million divided by 4 is
Look, I
25,
don't do that.
250,000.
Yeah, the only reason I know that is because 100 divided by 4 is 25.
Oh, I got you. Divided by it's
About
not
this.
I know that there's 4 quarters of a dollar. Quarters, 25 cents.
More I do this, I cannot.
All right, harder problem. I'm just gonna jump up to advanced level because we're low on time. I won't get enough time for that one.
But, oh,
Do you have a summary?
Yeah. Example 2.
how many computers did?
Oh, this is the one I got Diego last time.
So I
Which one is this one?
Last time.
have a batch of circuits.
Oh, yeah. Yeah, well, that got me last time.
Oh, log.
The natural log of
Yeah, we'll do that later. It's short. I need to have
Choose
short.
another one? Yeah, 3.
plus.
Do you have more? Is your total one?
Oh, I have to be careful here. I'm gonna make it a little bit natural log of just a number. And we're gonna make it equal to 10. All right, cool. Here we go. Again, you have to do Alden's first step of combining them into one logarithm. Let's see if Diego can do that for us.
So we have natural log parentheses.
We have one natural.
You got it. Natural log parentheses 7x plus 3 times 6.
Exactly. If you are adding the outsides, you're multiplying the insides.
Oh, yeah, and you're subtracting the 5.
Very good, yes. Haven't changed the right hand side. All right, I need to actually do that. So how much for that? I have fun. I'm not gonna worry. So this is gonna turn into natural log of, all right, distribute, ready, set, point. What do we get, Emma?
6, -6, right?
Yep.
And -x.
Very good. That's still equal to 10. I guess that could be why I logged in on Jupyter. And
I'll
then
know.
let's give this one to Alden. Alden, what do we do next? Get rid of one.
You add 6 on both sides?
Good guess, yes. But unfortunately, that 6 is trapped inside the parentheses. You need to get rid of the logarithm first. What's the undoing of a logarithm?
Oh, do base exponentiation?
Yeah, exponentiation.
You do base 10 on both sides.
Ooh, good guess, but not base 10.
E?
Yeah,
Right?
very. What were you gonna say, Diego? Yes. Diego was very eager on answering. It is base E. So I'm gonna say e to the power of all of this natural log of -14x minus 6 is equal to e to the power of, and as Alden predicts, this cancels, there's a base down there that theoretically cancels as well, giving us a -14x minus 6 is equal to e to the power of 10. And these are the types of answers that Diego dreams about, nice and disgusting ones. He likes them, I don't know. This is his thing, man. All right, so from here, we're gonna add 6 to both sides. Here we go, -14x, 6 is now gone, but on the right side it appears. Add 6 to both sides, there we go. Plus 6. And then what do we do? And we get our final answer is x is equal to e to the power of 10 plus 6 all divided by 14. It's gross, but that's the answer. There is a truly mean problem on the last 4 problems.
Wait, there's no solution.
Oh. Oh. Yeah. Okay, as a quick aside, I want to show something, caution. What happens if you have something that looks like this? X plus x plus 4 all over x. I'm gonna just make it x. Will that work out? Trying to make it come out to most solutions. It's harder to do than see. Just make it x. I'm gonna make that equal to. Oh, that's why it doesn't work. Yeah, one's the only thing that doesn't work. No. Yeah, go for it.
Is your name Sindel? No.
Okay, watch what happens when you're trying to solve something. This seems like unrelated to any of the math that we're doing up here, but eventually you might encounter something that looks like this. In fact, I can make it look really different than that, but take a look at this. From here, this is how you solve this problem. You move this one up here, and you say it's really 1 divided by 1, so it's a fraction equal to a fraction. You're allowed to rotate or go through the diagonals, right? I'm gonna move this x is gonna come up here. It's kind of like cross multiply, right? So I'm gonna have x plus 4 is equal to x. And watch what happens now. Minus x, 4 is equal to 0. Whenever you have something like this, this is no solution.
Did that pop up on our homework /quiz?
That will pop up on homework problem 5. And I'm gonna try to remember to put up one of these either on the quiz or the test.
At least one.
I'll try to remember. I might forget.
No, that's really mean though.
All right, that concludes the notes though. Let me get a really quick just a 5 on everyone. Whoa, 5, 4.5. I can't see these kiddos anymore. So if I stop sharing, 5 and 5. Let's go. Nice. All right. That concludes our lesson.